Alright, welcome to my channel. I am Dela, your online mathematics tutor. I'm going to take you through some interesting and insightful lessons. Make sure you stay tuned and subscribe to the channel. Thank you. Alright, so today we are going to look at sets for SHS 1 learners or learners that have completed BEC and are looking forward to be enrolled in the senior high school. Now, sets is not a new topic for those in SHS 1 in the sense that we did sets when we were in JHS. However, in SHS, there are some new additions to the lesson or the topic sets. Now in JHS, we looked at the 2-set problem. We are going to touch a little bit on that, and then we zoom straight to 3-set problem, which is the addition to the things we learned in JHS. Alright, so with the 2-set problem, alright, so with the 2-set problem, we can have these regions for the Venn diagram. Now, when we take this Venn diagram, we have the rectangle representing the number of U, and then we have the first circle representing number of A, the second one representing number of B, and then the part of A that does not include the intersection is known as A only, and then the part of the circle B that does not include the intersection of the two is also known as B only. And then we have the region in the rectangle that does not belong to any of the two circles, also known as neither A nor B. Is that okay? Now with this, in JHS we learned that when we are trying to equate everything to the universal set, we can say number of U is equal to our A only plus our A intersection B plus our B only, and then if we have neither A nor B, we say plus neither A nor B. Is that okay? Now, if we are to represent the regions, the names with regions, so that we have something like this: number of U are 2 circles. We do this number of A, number of B, but we name this side region 1, region 2. And then this is A intersection B, and we can say this is region 4. No, region 3, sorry. Right. Then in equating everything to the number of U, we can say region 1 plus the intersection of the 2 plus region 2 plus region 3, if there is region 3, is all equal to our number of U. Is that okay? Alright. Now, another way we can evaluate or equate everything to our number of U is by also using the formula. We say number of A plus number of B, okay, minus number of A intersection B. If there is this, then we do plus neither A nor B. Now, when we are to add this, we would also have our number of u. So there are two different ways we can look at it. Okay? Alright. Now, when we come to our two sets, alright, now when we look at the three set problem, that has to do with three different sets that are intersecting each other. We have the first set, that is our number of A, the second set being our number of B, and then the third set being our number of C. Then we have our number of U, which is the universal set that contains all the three sets, or is the mother set for all the three sets we are looking at. Now, I have named the various sections of this set into regions. So I have region 1, region 2, region 3, region 4, region 5, region 6, and then region 7. I'm going to take my time and then explain these regions. And then thereafter, I will take a question on three set problem, and then we'll look at how we can be able to solve that particular question. Now, region 1 has to do with the intersection of the three sets. So set A, set B, and then set C. They all meet at region 1. So region 1 is our A intersection B intersection C. That's our region 1. I believe you are with me. Then when we take a look at region 2 is the intersection between A and B. But we can't say region 2 is A and B intersection. Why? Because when we look at A and B intersection, it takes both the intersection of the three, as you can see. I'm deepening the lines. It takes both the intersection of 2 and then 1. And so our region 2 is the intersection between A and B only, because when we take into consideration intersection between A and B, it covers both the region 2 and region 1. However, if we want to describe only region 2, then we term this as A intersection B only. So our A intersection B only has to do with region 2. I believe you are getting it. Now when we come to region 3, we say region 3 is the intersection between B and C. But because we are not taking into consideration 1, we say region 3 is B intersection C only. So B intersection C only is equal to region 3. Then when we come to region 4, our region 4 will be A intersection C only. Then region 5. Region 5 is A only. The members that belong to only set A. They don't belong to any other set. So our region 5 is going to be A only would be equal to region 5. And then 6 would be C only. 7 would be B only. So that's the regions we have. So region 1 is A intersection B intersection C. Region 2 is A intersection B only. When we want A intersection B is region 1 and region 2 together. But region 2 is A intersection B only. And then region 3 is B intersection C only. If you want B intersection C, then that's going to be region 1 and then region 3. And then region 4 is A intersection C only. Region 5 is A only. Region 6 is C only. Region 7 is B only. I believe you get the naming of the regions. Please take note of them. It is very important. Going forward, we'll be referring to these things a lot. Alright. So if we want to write an equation for a number of u in the 3-set problem, we can say our number of u is equal to the addition of all the regions. In other words, we say region 1 plus region 2 plus region 3 plus region 4 plus region 5 plus region 6 plus region 7, and then the last one that I didn't talk about, region 8. Now region 8 has to do with the number of people or the set of people that did not belong to any of the 3 sets under review. They don't belong to set A, they don't belong to set B, they don't belong to set C. However, they belong to the universal set. So all those members that are not in A, B, and C, but they are in the universal set, are those that find themselves in region 8. And so we can say region 8 is A union B union C, all complement. You understand? A union B union C, all complement. That is region 8. Now, another way we can equate everything to our universal set is by saying number of A, that is we pick all of this, plus our number of B, plus our number of C. Okay? Then minus number of A intersection B minus, I'm continuing at the down, number of A intersection C minus number of B intersection C, then plus number of A intersection B intersection C. Alright, so this is also another way we can write an equation for a number of u. So I would advise you keep the two equations. As we are moving forward, we will be making use of them. Alright, so we have our first example on the 3-set problem. In a class of 45 students, it is known that 24 of them do arts, 20 do chemistry, and 22 biology. All the students do at least one of the 3 subjects. 3 do all the 3 subjects, while 7 do arts and biology. 6 do arts and chemistry, but no biology, and 8 do chemistry and biology. How many students do I? Biology only, chemistry only, or arts only? I. 2 subjects only. So this is a typical 3-set problem, and we are going to look at how we would arrive at the solution. So, first of all, we can write the important things from the information that has been given us. We know that in the class there are 45 students. So our number of u is going to be 45. And then it is also known that 24 of them do arts. So we say let the number that do arts, which is number of A, be 24. 20 do chemistry. So we say let the number that do chemistry, which is number of C, also being equal to 20. And then the number that do biology, which is number of B, let that one be 22. So number of B, 22. Now moving forward, we are told that all students do at least one of the 3 subjects. What this particular statement is telling us that we don't have any complement. So there wouldn't be any sets in region 8. That is those that do not belong to A, B, or C. That means every student is studying at least one of the theory subjects. So we are not going to have region 8 in this particular question. Now, theory do all the theory subjects. So we have our number of A, intersection B, intersection C, being equal to 3. While 7 do arts and biology. So our number of A, intersection B, arts, intersection biology is 7. 6 do arts and chemistry, but not biology. 6 do arts and chemistry, but not biology. So in other words, we are talking about those that do arts and chemistry only. So number that do arts intersection chemistry only is equal to 6. And then 8 do chemistry and biology. So number of chemistry intersection biology is also 8. So these are the information we can get from the question that is given us. And from this information we can draw our 3 set problem. So we draw our sets. Our number of U is 45. We have 3 intersecting sets. Our number of A is 24. Number of B is 22. Number of C is 20. We are told that A intersection B intersection C, the intersection of the 3 is what? 3. Number of A intersection B. Now, A intersection B covers all these regions. So all these region is 7. But out of the 7, a portion of it is 3. So what would be the other portion left? That would be 7 minus 3. And that should be what? 4. Now A intersection C only. A intersection C only is only this region without the intersection of the 3. So we are going to put all the 6 there. And then C intersection B. That is this region. C intersection B is all this region, including the intersection of all the 3. Therefore, if it is 8, and then out of that 8, a portion of it is 3, what will be the rest? That would be 8 minus 3, and that should give me 5. I believe you have gotten it. Now, we represent our information on the Venn diagram, and now we should be able to solve or answer the question that is being asked of us. I says the number that do biology only, chemistry only, or arts only. Are you with me? So we can calculate. This is arts only, biology only, chemistry only. It's a matter of just addition. So when we come to arts only, going to be the total of this circle is 24. However, we have a portion. So we are going to have 24 minus into bracket 4 plus 3 plus 6. Now it's going to give me 24 minus this 7. Okay, 7 plus 6 should give me 13. And when I do my subtraction, 13 being subtracted from 24 should give me 11. Therefore, arts only is 11. Alright, so we are done with the arts only. We move on to calculate for biology only. So biology only. That would be this particular region, biology only. But we know that the total circle or the total of the biology set is 22. So to find this is simply 22 minus into bracket the addition of all the other regions. So 4 plus 3 plus 5, and that should give me 22 minus 4 plus 3 is 7, and then 7 plus 5, that is 12. So this should give me 10. And then the last is chemistry only. We know that the total circle for chemistry is 20, that is the set. And then we are supposed to find this region, so that's also going to be 20 minus into bracket 6 plus 3 plus 5, and that will give me 20 minus 6 plus 3 would give me 9, and then 9 plus 5 would give me 14. So 20 minus 14, that should give me 6. Therefore, my art only is 11, my biology only is 10, and then my chemistry only is 6. So I have 11, 12, 6. So the I part of the question, that says you should find the number of students that do biology only, or chemistry only, or art only. We have it here, art only 11, biology only 10, chemistry only 6. Now 2 subjects only, 2 subjects only. That means only art and biology, or biology and art only, biology and chemistry only, art and then chemistry only. So we're looking at the onlys, 4, 5, and 6. So our II would be 2 subjects only, would be 4 plus 6 plus 5, and that should give me 10 plus 5, which is 15. Therefore, our 2 subjects only is also equal to 15. So this is the solution to our 3 set problem. Alright, we would end here. Make sure you like the video and then you subscribe as well. Thank you.